5. Calculate the absolute pressure at an ocean depth of 2,000 meters. Assume that the density of the water is 1.025 times 10 to the third kilograms per meter cubed, and that P naught is 1.01 times 10 to the fifth pascals. And number 6, the Marianas Trench in the Pacific Ocean is about 11 kilometers deep. If atmospheric pressure at sea level is 1.01 times 10 to the fifth pascals, how much pressure would a submarine need to be able to withstand to reach this depth? All right, let's look at number 5. We have a depth of 2,000 meters under the ocean. A depth is given by H. That's 2,000 meters. Assume that the density of water, the density of water is 1.025 times 10 to the third kilograms per cubic meter, and that the pressure due to the atmosphere, P naught, it's 1.01 times 10 to the fifth pascals. I'm just going to go ahead and use 101.325 pascals. Now, absolute pressure is equal to the pressure of the atmosphere, P naught, plus rho GH. So P is equal to 101.325 plus the density of the ocean water times gravity, which is 9.81, times the oceanic depth. You're going down to a depth of 2,000 meters. And really the only thing you have to do now is just plug this in a calculator. And we get 101.325 plus 1.025 times 10 to the third, 9.81, 2,000, and we have 202.11825 pascals. We'll just round that to 2.02 times 10 to the seventh pascals. All right, let's go ahead and do number 6 as well, because it's essentially the same problem type. And in number 6, you're in the Marianas Trench in the Pacific Ocean. It's about 11 kilometers deep, so that's a depth H of 11,000 meters. The atmospheric pressure at sea level, P naught, is 101.325 pascals. How much pressure would a submarine need to be able to withstand to reach this depth? And essentially we have the exact same equation. The absolute pressure is the atmospheric pressure plus the pressure at that depth. The pressure at that depth is always given as rho GH. So the absolute pressure is equal to 101.325 plus the density of seawater is 1.025 times 10 to the third. That's either memorized or it comes from a table from the textbook, 9.81, and the depth is 11,000. This gives us an absolute pressure of 1.107 times 10 to the 8th pascals. And that's 5